how to create a fin from an image of its outline. Here, we open a board. We will remove the existing fins. And we are going to go faster. To remove fins, and create a static fin, we will simply do all static, here, single. Which therefore erases the existing configuration, and replaces it with a single. So now that we just have a single static fin in our project, we can edit it, do pretty much anything with it. So I select it either here, or in the tree, at the bottom, in the fin tab, and use the static fin editor. So the static fin editor allows us to choose an outline. Choose the profiles of a given fin to create our line according to an already existing image. So we're going to use an image of fins in a drawing editor, and we just crop the it so we get the working surface of the fin we're interested in. So the working surface, we don't count the box, and we'll go to the leading edge here. And we make a rectangle that just takes the most precise fin possible. That's best. So we're fine coming up clean on the back here. There you go, we have our fin design that has been created. Just take the working part. And so we have our fin base. And we save this image in JPEG format. Here, we will call it future fin. Save. So now that we have our base image, we will be able to import it into our fin editor with this function. Here, load image end outline. I'm going to fetch the image we just created, future fin, and we see loading here. We're going to adjust our outline. To match this shape we can see in the 3D diagram here, modifications. So there are little editing functions here that save us a bit of time. For example, smooth select, it allows us to select a series of points and move them in a way as if they were linked to a chain. And this therefore makes it possible to have more fluid movements on a set of points. So we come to approach the shape very roughly like that without worrying too much about it at the start. Here, we are going to use this function here, which therefore softens the points, which is smooth here also at the back. We will then uncheck this smooth select function so that we can really apply each point at will. So we could keep this function, smooth select, to draw several points, and then to adjust the points, we will use the right arrow on the keyboard to take the point where we want. This allows you to go with good precision, and quite quickly, to the desired contour point. So we're going to adjust here. And so we're going to adjust our outline like that to get our fin. So you will notice that we do not talk about dimensions when we do this work. That is to say that we do not worry too much about the dimension at the height of the fin, which interests us its form. So you understood. A little bit of patience and precision to get our fin. And here is our fin. So once the fin seems to match your objective, we save it, so we apply it. It's here, and we'll select here and save the fin, save single static as. And here we'll save it for future testing. When the fin is saved, we can modify its size and adjust it to the dimension of its series. In general, a fin of a certain shape is sold in different sizes to choose the right surface. Here we could adjust from 145 to 135 to 108, which is a more common size. We will now look at the fin profile. So I select fins. Here, edit fin selected. And I get my fins editor. Here we are in symmetrical profile in the list. Here we see selected, symmetrical. If I select here the list of flat profiles I have at my disposal, a series of flat profiles that I can apply. Here we have a function that applies to all the profiles of the fin. We could apply only to one profile, the selected profile, so when I select a point it changes. Here I have selected profile 5, and if I select profile 0, I might want a different profile. Here, we will stay on a NACA 2410 flat profile, and we will apply it to all profiles. So here I apply and I close, and so we see here I have a fin with a flat side, the upper surface here, and a flat lower surface. So we see that it is a side fin. I could immediately put 50 mm, 100 mm aside. We're going to put it less. And simply come and place it at the right distance. Here we will come to 330, 150. And we could therefore adjust the fins as desired. Here we are going to create the symmetrical fin right away, so no need to recreate the fin. There is an automation of the inversion that is done. And so here we have created our symmetrical fins. Of course, we could save the fin. Here, we select and save our fin. Here, we're going to call it lateral future. And we're recording that. So our fins are placed in the library. Here we see the fins that we've created. Then there is the center, I think. There. And we have ours set. We might now want to create an STL copy of this fin to generate a 3D print, or simply cut it out using numerical control to make fin blanks. We select the fin we want in those that are edited in the project. And we have an STL export function that allows us to export the STL. At the bottom we see the construction in progress. Here is the STL, we'll call it STL future tests. So I save it, and now we'll look at this file, STL in 3D software. SolidWorks like. So, here we open our STL file, and therefore we see our fin in STL format. Ready for 3D printing or CNC machining. That's it for this fin creation tutorial with Shaper Wave Dynamics software.